Hey everyone, I will give a presentation to our work on capacity and cost efficiency optimization in front-end servers of data center. So the title of our work is CETUS towards proportional capacity provisioning and cost effectiveness in front-end servers. So let's first go to the background and the motivation. So in a production hyperscale data center, which provides a variety of services such as search and social media networking and so on to billions of users, the TCO cost has become one of the key design considerations because of the significant amount of servers. Therefore, capacity provisioning needs to be planned ahead carefully. Today's scale-out data centers have widely adopted the multi-tier approach, where servers are organized as clusters, and each cluster serves precisely a single role. So the front-end cluster are composed of the web cluster and the application cluster. The web cluster steers the user-facing traffic to the application cluster with respect to their load. In practice, the web cluster can oftentimes be consolidated with the application cluster, and the backend cluster usually provides database services and a distributed storage to the front end. So this slide illustrates an example of such a configuration. In the TLS acceleration case, there were multiple inefficiencies in the front-end architecture despite of being widely deployed. For example, the adoption of the TLS accelerator not only brings in the differentiations, but also needs to solve the match issue, which we will cover shortly, issue of the web cluster to the application cluster, and another match issue of the crypto accelerators to the system capacity. So the capacity of each cluster needs to be provisioned proportionally to prevent resource underutilization and starvation. In other words, the aggregated connection per second by the web cluster should match the aggregated transaction per second of the application cluster. And to handle these scenarios, we propose CETUS, a novel front-end architecture designed to address the inefficiencies in existing front-end clusters of hyperscale data centers. So CETUS enables the consolidation of web cluster into the application cluster while maintaining the same level of throughput and latency, and thus can significantly reduce the cost of the front-end cluster. The transfer layer security of TLS brings in authenticity and confidentiality and integrity to the HTTP, and the TLS supports creates a new protocol layer over the traditional network stack, and uses the asymmetric or symmetrical cryptography algorithms to conduct the handshaking and data encryption and decryption. As shown in this slide, in order to retrieve a 4 kilobytes web page, more than 85% of the time is spent on processing the TLS and the network stack, and among which TLS alone incurs about 60% of latency overhead. Obviously, we need to seek a more efficient approach to accelerate the TLS operations in the CETUS. So once the cipher computation gets offloaded to the TLS accelerator, the code left on the web cluster is essentially networking-centric code, such as layer 7 load balancing and rate limiting. Constructing clusters of general-purpose commodity servers to run the single-purpose networking-centric code is not economic for the data center. So in fact, as shown in the slide, when interpreting how efficiently x86 handles TCP/IP processing using a more costly neutral metric, such as the connection per second normalized by the effective die area, commodity Xeon servers are not the most efficient solution for dealing with the network stack and load balancing as web servers. Recently, some enhancement has been proposed to move the networking layers from kernel space to user space, such as DPDK. However, CPU still needs to be assigned even when there were no network flow to host. So remember, just now we have mentioned the multiple match principles that in our idealized design. So specifically, this means the following: although data centers are often over-provisioned in order to provide high availability and better latency during the peak hours, the capacity of the individual cluster still needs to be designed proportionally. So in a well-provisioned data center, there should be 3 dimensions of match principles. The first level is the inter-cluster level, where the aggregated connection per second of the web cluster must match the aggregated transaction per second, or TPS, of the application cluster. And in the intra-cluster level, the aggregated CPS provided by the CPUs in the web cluster in handling network stack should match the aggregated operational per second, or OPS, provided by the TLS accelerator. And in the third level, which is the intra-server level, the CPS provided by the CPU of an individual server in the web cluster should match the OPS provided by one or more TLS accelerators in that server. So, but in practice, meeting the three criteria at the same time is almost impossible. It's very difficult. So in order to address these issues, we propose the CETUS. And now let's just dive into the CETUS architecture and show how it can help to eliminate the problems. So CETUS is a new data center front-end architecture to cope with the cost efficiencies and the capacity provisioning hurdles. CETUS is implemented as a SOC architecture to achieve the same functionality and the same level of performance as the existing web tier servers. In general, the CETUS SOC serves as a peripheral to servers in the application cluster, and it allows the complete consolidation of web cluster and the application cluster to achieve a more cost-effective approach. The CETUS SOC includes a TLS accelerator, power-efficient CPU cores, network adapter, and a flow diverter into the same die. Packets received on the networking ports of the CETUS card can be forwarded to the small cores for network stack processing. Since the root cause of the unproportional capacity provisioning is that the hardware resources for network stack processing and the various cipher suite accelerators can only be determined statically at manufacture time. So we have to introduce more dynamics in the resource provisioning. So specifically in CETUS, we introduce a hardware flow diverter, which allows the small cores to spill the networking stack processing task to the hosted CPUs or to other CETUS SOCs in the cluster at runtime, depending on the specific workload intensity. The inclusion of the network adapter and the flow diverter in the SOC essentially forms a logical pool of the SOC of the CETUS SOC resources and enables dynamic division of the cipher compute acceleration and the network stack processing among all the resources in the front-end cluster. CETUS employs a decoupled design paradigm that separates the basic operation modules from the control logic and wraps them in a tile that can be reused by the cipher algorithm. So, as can be seen in this slide, each tile contains a complete set of basic operation modules required to run these algorithms, including modular operators, pseudo-random number generations, and also the comparison. So the flex tile selectively activates the functional modules based on the command sequence, and a pool of flex tiles is capable to deliver the same sustainable CPS on the small cores for networking stack handling as the OPS on the TLS accelerator block. And in practice, we over-provision the TLS acceleration capacity and rely on the flow diverter to dynamically balance the network traffic. So now let's just take a closer look at the flow diverter. So the flow diverter is not intended to replace the layer 7 load balancer. Instead, the flow diverter coexists with the layer 7 load balancer and only aims to balance out the TLS related traffic among the CETUS pool, which may further spill over to the application servers. So the structure of the flow diverter is similar to a simplified open flow switch, and the traffics flow through a series of open flow tables. So this slide shows a little bit more details about the specific policy that we implement in the flow diverter. So once programmed the flow diverter in the CETUS SOC on the node, we find a 5-tuple match table and choose the appropriate balancing policy out of the 3 levels. The first level is a local policy, which steers the traffic from the CETUS SOC to the host CPU in the same node. And when the loads of the core CETUS SOC are larger than a given threshold. And beyond that is our second level policy, which is a nodal level policy. It is responsible for steering the traffic from one CETUS SOC to another CETUS SOC in the same node when there are multiple CETUS SOCs coexist in the node. And finally, the third level is a global policy, which steers the traffic from one CETUS SOC in one node to a CETUS SOC in another node. And in this particular study, we only focused on the first two policies. That means the local policy and the nodal policy. The TOS accelerators are also accessible from for the host CPU to offload the cipher computation. Now let's look at the workflow corresponding to this architecture, and we will use the TOS handshake in CETUS to illustrate the flow. So host may receive a TOS handshake only when the flow diverter is turned on, and the TOS handshakes are entirely processed on CETUS SOC when the flow diverter is off. The network adapter on CETUS serves as the regular NIC card and forward packets to the small cores by default. So in this case, the network stack is processed on the small cores, and the application layer then invokes the open SSL libraries such as libSSL and libcrypto for further processing. The benefit of this architecture is that it can optimize both the system performance and the cost efficiencies. First, the end-to-end latency of a network request processing is considerably reduced, which consists of the long queuing delay in NIC card and the TCP/IP SSL protocol stack handling. In specific, DMA transactions between the NIC and the small CPUs are carried through the AXI interface instead of the PCIe, and this can save a significant amount of cycles in data link layer and the physical layer. Also, the user space TCP/IP protocol can help eliminate the overhead for context switching between the kernel and user space execution. The time-consuming crypto computation heavily used in the SSL protocol has been offloaded to the SOC, relieving the expensive high-end CPUs on the host system for actual customer usage. So now let me just demonstrate some evaluation results of the SOC and highlight its benefits. So the tests are conducted with a concentration on the operation and the cost efficiencies and also the impact on the performance in terms of throughput and latency. So CETUS SOC is implemented based on a 28 nanometer process, and we choose an ARM A72 as the small core. The server platform used for the evaluation is a dual-socket Xeon Broadwell, and we also have a system installed with the Intel's QAT card for the comparison. So we start our evaluation by sweeping the concurrent HTTP request sent to the server and measure the CPS and host CPU utilization. So as can be seen from this figure, which is corresponding to the RSA 2047, there are three distinct phases of the host CPU utilization curve. So at the beginning, the host utilization is close to zero when the HTTP traffics are relatively light, and all the TOS transactions are processed by the CETUS SOC. And as the request number increases, the small cores become saturated, and the flow diverter uses the local policy. Then the host CPU utilization slowly increases until the flex tail in CETUS SOC is also fully loaded. And after that, the nodal policy is engaged. So this results in almost identical performance as the QAT in asynchronous mode, but with the CPU utilization not exceeding 30%. And in contrast, the CPU utilization of the QAT reaches almost 70% in order to deliver the same level of the CPS. And for the cost analysis, we use the dollar per performance as the metric to compare our CETUS front-end architecture. We use peak CPS measured and the different RSA key length and divide the price of each solution respectively. So in specific, the dollar per performance is derived by this equation. the DP denotes the dollar per performance, and the solution price of the CETUS is calculated by dividing the manufacturing cost composed of tape out, a wafer, and a PCB cost, etc. by the number of chips. According to the details of the cost composition analysis, CETUS achieves roughly 85% cost reduction in both RSA key lengths when providing the same level of performance as QLT adapter. And the reason of this significant cost reduction is mainly that the elimination of the entire web cluster built with the commodity servers. Finally, we also show some performance data. So for both the RSA key length, the CETUS achieves much better CPS than that of the QLT card in the synchronous mode. And in the scenario of the RSA 2048, our measurement clearly demonstrates that the hosted CPU utilization with QLT reaches almost 70% as opposed to be completely free when using CETUS. And also note that once the RSA key length increases, the performance of the CETUS relative to the QLT also increases. This is mainly because of the crypto computation increasing exponentially. So we also show the CDF of the response time corresponding to the RSA 2048. As can be seen from this slide, the average response time of the CETUS statically lays between the QLT and the x86, with this mean value about 4 milliseconds faster than the x86 and about 2 milliseconds slower than the QLT. So, in summary, the proposed CETUS SoC enables cluster consolidation and saves cost for building the front-end servers. So because CETUS leverages SoC architecture that fully offloads the web cluster and results in the consolidated front-end with a significantly higher efficiency. And also it includes a hardware solution, the hardware diverter that to create a logical pooling of the CETUS resource, so it can ensure the various resources in the front end can be provisioned proportionally. And also by allowing this flexible forwarding of tasks among the SoC and hosted CPUs, the proportional capacity provisioning is achieved. But as part of our future work, we will further explore the strategies for the global flow directing between the aggregated CETUS SoCs in order to bring more efficiency to the data center front end. So thank you everyone. This is my presentation.